The spectacular aurora light displays that appear in Earth's atmosphere around the north and south magnetic poles were once mysterious phenomena. Now, scientists have data from satellites and ground-based observations from which we know that the aurora brilliance is an immense electrical discharge similar to that occurring in a neon sign. To understand the cause of auroras, first picture the Earth enclosed by its magnetosphere, a huge region created by the Earth's magnetic field. Outside the magnetosphere, blasting toward the Earth is the solar wind, a swiftly moving plasma of ionized gases with its own magnetic field. Charged particles in this solar wind speed earthward, along the solar wind's magnetic lines of force with a spiraling motion. The Earth's magnetosphere is a barrier to the solar winds, and forces the charged particles of the solar wind to flow around the magnetosphere itself. But in the polar regions, the magnetic lines of force of the Earth and of the solar wind bunch together. Here many of the solar wind's charged particles break through the magnetosphere and enter Earth's magnetic field. They then spiral back and forth between the Earth's magnetic poles very rapidly. In the polar regions, electrons from the solar wind ionize and excite the atoms and molecules of the upper atmosphere, causing them to emit aurora radiations of visible light. The colors of an aurora depend on the atoms emitting them. The dominant greenish-white light comes from low-energy excitation of oxygen atoms. During huge magnetic storms, oxygen atoms also undergo high-energy excitation and emit a crimson light. Excited nitrogen atoms contribute bands of color varying from blue to violet. Viewed from outer space, auroras can be seen as dimly glowing belts wrapped around each of the Earth's magnetic poles. Each aurora hangs like a curtain of light stretching over the polar regions and into the higher latitudes. When the solar flares that result in magnetic storms and aurora activity are very intense, aurora displays may extend as far as the southern regions of the United States. Studies of auroras have given physicists new information about the behavior of plasmas, which has helped to explain the nature of outer space, and is being applied in attempts to harness energy from the fusion of atoms.